Hi, welcome to our electromagnetic theory course. In today's class, we will discuss about impedance transformations. Impedance transformations. In last class, we derived input impedance for lossless transmission line as Zin is equal to what? Z0 into ZL plus JZ0 tan beta L, tan beta into L by Z0 plus JZL tan beta L. In the last class, we derived the input impedance of lossless transmission line is like this. Basically, this lossless transmission line is used for power transmission or power distribution. Okay, if you see this expression for input impedance, this is functions of what? That is, it clearly shows that Zin is, from this we can say Zin is functions of what? That is Z0, ZL and length of the line. Length of the line. Here it is functions of Z0, ZL and this L, where beta is constant. Beta is 2 pi by lambda for the given wavelength. Okay. So now if length changes, this impedance changes. Means what? If length changes, impedance is transformed to another value. So that's why here we consider a transmission line of different lengths, length equal to lambda by 8, length equal to lambda by 4, if length equal to lambda by 2, that line is called as lambda by 2 line. Let us consider these three different lines of different lengths, that is lambda by 2, 8, lambda by 4 and lambda by 2. Now, if you go for that case 1, so case 1 means I consider the length of the line is L equal to lambda by 8, or simply, or else case 1 for lambda by 8 line, for lambda by 8 line, or else length of the line, lambda by 8 line means what? The length of the line is lambda by 8. Now, substitute this L equal to lambda by 8 in this equation, and let us take this equation as equation number 1. Now, where you have this L in the numerator and denominator, of course it is what? Here we have L, in this case it is tan beta L. In order to find input impedance for that lambda by 8 line, we need to substitute L as lambda by 8 in that equation. First find this tan beta L. Therefore, tan beta L for lambda by 8 line is given by tan beta. We know that beta is what? 2 pi by lambda. Beta equal to 2 pi by lambda. And length is given as what? For the lambda by 8 line, that equal to L equal to lambda by 8. Since here we considered what? That is the length of the line L equal to what? Lambda by 8. The length of the line is what? Lambda by 8. Now this lambda cancelled out. 2 pi by 8, that gives what? That is tan pi by 4. What about the value of tan pi by 4? Tan pi by 4 equal to 1. Substitute this tan beta L in this one. We will get what? Substitute tan beta L equal to 1. Here we got tan beta L equal to 1 in equation 1 to get input impedance of the lambda by 8 line. Therefore, Zin of lambda by 8 line we can write like this, that is Zin of lambda by 8 line equal to what? Input impedance of the lambda by 8 line is equal to what? That is Z0, ZL, JZ0 into 1. Tan beta L value is 1 by divided by Z0 plus JZL, J into ZL, and tan beta L value is 1. Finally we got, that is Zin equal to what? Z0 ZL plus j z naught by z naught plus j z l. Now it is purely functions of z naught and zl only. This is the expression for what? Zin of lambda by 8 line, that is input impedance of the lambda by 8 line. Okay, so let us take this as what? Equation 2. Please remember these equations 1, 2. Okay, we will write all these equations at one place, means we need to write this equation 1, for this one another, that is equation 2, for this one equation 3, for this one equation 4. From this we can say that the impedance, this equation 1 is transformed to like this. That means what? There exists impedance transformation if length changes. And we will go for, that is case 2, by considering a lambda by 4 line. Lambda by 4 line means what? The length of the line is L equal to lambda by 4. Case 2, it is case 1, that is case 1, this is case 2. So for the case 2 is nothing but what? For lambda by 8, lambda by 4 line, that is second line, for lambda by 4 line means the length of the line is what? L equal to lambda by 4. Okay, now find tan beta L. In this case, for this case, you can write like this, for this case tan beta L. So here also same thing, for this case tan beta L equal to what? Tan beta means 2 pi by lambda. Lambda is 2 pi by beta, or else beta equal to 2 pi by lambda. And L is what? We considered L as what? That equal to L can be taken as, in this case for the lambda by 4 line, it is lambda by 4. Since beta is 2 pi by lambda, I forgot to write that thing here, that is what? Beta is 2 pi by lambda, and L is considered as what? Beta is 2 pi by lambda, and L is, in this case, L equal to what? Lambda by 4 line. So that's why after simplification we will get this lambda cancel out, 2 pi by 4, that is tan pi by 2. Tan pi by 2 means what? Infinity. It is what? Infinity. Okay. So now first let us write this Zin. Equation 1 can be rewritten like this, that is equation 1 can also be written as Zin. If you have numerator and denominator, okay, if there exists infinite term, that is infinite plus something, that gives what? Infinite in the numerator, in the denominator also infinite plus something infinite, so that is it gives what? Infinite by infinite form. So it is what? It gives undefined form. So that's why if you have infinite by infinite form, go for like this. If you have numerator and denominator, in that case take that infinite term as common in the numerator and denominator. So if I take tan beta L as common in the numerator and denominator, we will get like this, that is Z naught. Okay, let us take that infinite term as common. So what is the infinite term? Tan beta L, so that is infinite, is equal to what? If I take tan beta L as common, here we will get what? ZL by tan beta L, ZL by tan beta L, ZL by tan beta L, plus remaining term. If I take tan beta L as common, remaining term is what? J Z naught for this second term, and go for the denominator. In the denominator, tan beta L is taken as common, tan beta L is taken as common. So if I take tan beta L as common, here we will get what? For this one, Z naught by tan beta L, that gives Z naught only, Z naught by tan beta L plus J. If tan beta L is taken as common, remaining term is what? J into ZL, J into Z suffix L. So that is load impedance. Now this tan beta L cancelled out. And what about the remaining term? I will write that remaining term here. We require this equation 1 for the that lambda by 2 line also. So it is for what? It is for lambda by 8. That is equation 2. Now after simplification we will get what? That is Zin equal to what? Therefore I will write this one here. So Zin is equal to Z0 into ZL by tan beta L. What is ZL by tan beta L? That is infinity for the lambda by 4 line, plus JZ0, and here we got what? That is Z0 by infinite plus J ZL. So that is something by infinity gives what? That is Z0. Something by infinity gives 0, and here J Z0. Here something by infinity gives 0. So that is J ZL. Now this one cancelled out. We will get what? That is Zin for what? Actually indirectly here I consider tan beta L is infinity, means what? I need to take this as what? I need to take this as Zin lambda by 4 line. So therefore for Zin lambda by 4 line we got expression as what? That is Z0 square by ZL. So input impedance, that means equation 1 is transformed to like this for the lambda by 4 line. So that means what? Impedance is transformed, okay, like this. From this we can write this ZL equal to what? Or else I can write that Z0 square as what? Zin into ZL. So means we can write like this, that is root of Zin lambda by 4, Zin lambda by 4, Zin lambda by 4 into ZL. Send this term to this side, we will get what? Zin lambda by 4 into ZL is equal to Z0 square. Then Z0 is what? Under root of Zin lambda by 4 into ZL. This is what? Now we can say this characteristic impedance for the lambda by 4 line is nothing but what? Mean of the GP series. It is just as suppose I have A, B, C in the GP series, then B is what? B is nothing but the mean for these two, that is B equal to root A, C for the GP series. Now here also Z0 is transformed as what? Okay, the mean of that GP series for Zin lambda by 4 and ZL. Next, or else Z0 is simply like this. Okay. Next, last one for lambda by 2 line, for lambda by 4, for lambda let us take that is case 3. It is for what? Case 2. So it is the equation number 3. You can take this as equation number 3. And last one, that is what? Go for the last case, that is case 3, that is for lambda by 2 line, L equal to what? Lambda by 2. For this case, tan beta L equal to what? Tan 2 pi by lambda, that is beta is 2 pi by lambda, and the length of the line is here lambda by 2. So lambda cancelled out, and here it is becoming what? Tan pi. What about the tan pi value? That is 0. Tan pi value is what? 0. Now substitute this one, that is tan pi equal to 0 in equation 1. Substitute tan beta L equal to 0. Here we got tan beta L as 0 if L equal to lambda by 2. Substitute tan beta L equal to 0 in equation 1. If we substitute this tan beta L equal to 0 in equation 1, we will get expression for that Zin. We will get the expression for Zin. This is the what? Input impedance of the lambda by 2 line, because we consider length of the line as lambda by 2. Now we can write that as what? Z0 ZL plus JZ0 into 0, and here Z0 plus J ZL into 0, because tan beta L is tan pi, that is 0. So finally we got this one as what? Z naught into ZL by Z naught. Okay, this is 0, this is also 0. So this becomes 0, 0 into something 0, this is also 0. So finally we got Zin for lambda by 2 line is nothing but what? Zin for lambda by 2 line. It implies Zin for lambda by 2 line is nothing but what? ZL. So let us write this as equation 4. Equation 4. We have equation 1, equation 2, equation 3, equation 4. Now let us write all these equations at one place. That is, equation 1 is like this. Equation 1 is like this. And equation for the input impedance of the lambda by 8 line is given by, that is equation number 2. Already we derived. That as what? Zin lambda by 8 equal to Z naught into ZL plus JZ0 by Z0 plus JZL. This is equation number 2. Next, let us write that equation number 3. What is equation number 3? That is, input impedance of lambda by 4 line is given by, is nothing but what? Z0 square by ZL. Z0 square by ZL. Now let us go for what? Let us go for what? That is Zin lambda by 2 line. Just now we derived, that is Zin lambda by 2 line. For the Zin lambda by 2 line, it becomes what? ZL. So let us take this as equation number 3. This is equation number 4. Means what? If length of the line is changed to lambda by 8, lambda by 4 and lambda by 2 line, then impedance is transformed like this. Okay, in this case input impedance equal to the load impedance for the lambda by 2 line, and for the lambda by 4 line, so lambda, it is a lambda by 4 line. This lambda by 4 line is also called as lambda by, please make a note of it, lambda by 4 line is also called as lambda by 4 line. This is what? Quarter wavelength. Quarter wavelength. 1 by 4 means quarter. So this is called as what? Quarter wave length. So that's why lambda by 4 line is also called as, lambda by 4 line is also called as quarter wave transformer. Quarter wave transformer. Quarter wave transformer. It can be, the application of lambda by 4 line is, it is used as impedance matching device. Application of quarter wave transformer is, it can be used as impedance matching device between source and load. It can be used as what? Impedance matching device. It can be used as impedance matching device to get maximum power at the load end, or else to deliver maximum power we require the impedance matching between source and load. For that impedance matching, we can use our lambda by 4 line or quarter wave transformer as impedance matching device. This is all about impedance transformations. We will meet in next class. Thank you.